All right, so this is your Dido mini lecture here if you were gone on Friday. The first thing you want to make sure gets into your notes is what you see here in this chart. Specifically, you've got on the right-hand side here your lenses, your converging and diverging lenses. So what you need to know about converging and diverging lenses is that a converging lens, by definition, is a property of the lens. It has a positive focal length, okay? So diverging lenses have a positive focal length, okay? And then, of course, a diverging or concave lens has what we call a negative focal length, okay? Please make sure this chart gets in your notes. Pause the video if you have to. Okay, in addition to this, the chart you wrote down, you also need to put down what your image lengths are, or the sign of your image and object lengths. So the first thing we're going to talk about is image lengths. The left-hand side of this chart with your mirrors, you have seen this before. Over here you've got, with your mirrors, with our diverging mirror, remember it makes a virtual image, which we always call negative. Down here with your concave mirrors, we know that with a concave mirror, remember, it can make a real or virtual image. So when the image is real, we called it positive. When it was virtual, we called it negative. It's kind of the same idea with lenses. Okay, over here with our lenses, you've got let's start with the converging lens. When you have a virtual image, so the image shows up on the same side as the object, we call that image distance negative. When the image is real and it shows up on the other side of the lens, we call that positive. Okay, so virtual negative, real positive. And then the same thing can be said for diverging. Of course, with diverging, you always make a virtual image, so the image distance is always going to be negative for your diverging lens. So the equation itself here, of course, is the same one we use with mirrors, 1 over di, so 1 over the image distance plus 1 over do, which is the object distance, is equivalent to 1 over your focal length. So let's take a look at a quick practice problem here. Let's make sure we can do this. So with this problem, we've got an object placed at a distance of 1.5 meters behind the lens. It's going to result in an image being formed at a distance of 0.75 meters in front of the lens. Our job is to find the focal length of this lens. So to put this in perspective, we know that the object is 1.5 meters away. Okay, and our object distance for all of these problems, the object distance is always going to be positive. So I have a positive 1.5 for my DO. I'm also told that my image shows up on the other side. That means that I have a real image. Meaning, if you took notes on the last page, remember when you have a real image, we consider that distance to be positive. So we have our DO and our DI, meaning we can now solve for our focal length. So I'm simply going to start with my equation, which of course is 1 over DI plus 1 over DO equals 1 over f. And then we're just going to substitute in what we know, which is our di, which happens to be 0.75 meters, plus 1 over do, which is 1.5 meters, and that's equivalent to 1 over f. Now, what we can do is we can go ahead and just punch in our calculator, right, and find out what is 1 over 0.75, find out what is 1 over 1.5, and then we can simplify and solve for f. So when we're doing that, what we're going to simply do here, in my calculator, I do 1 over 1.75, and that is, let's see, when I punch it in, I get 1.33, and that's inverse meters, plus 1 over 1.5, which is 0.67 inverse meters, and that's equal to 1 over f. Now I just simplify. I add my 1.33 to my 1.67, and I get 2.00 inverse meters is equal to 1 over f. And then I'm simply going to inverse both sides of the equation, and I will get 1 over 2 is equal to, which is 2.00, let me clarify that, 1 over 2.00 inverse meters is equal to f, and 1 over 2.00 inverse meters is simply 0.5 meters. So that tells me that my focal length is 0.5 meters for this specific lens. So it's pretty straightforward. What we're really talking about here is this focal length right here. This distance is 0.5 meters from the front of the lens, and really it's also this distance here on the back of the lens is also 0.5 meters, because remember, the focal length is on either side of the lens. We went ahead and solved that. Again, so let's do one more example very quickly here. Let's do a diverging lens. So for your diverging lens, we're told it's going to have a focal length of negative 0.75 meters, okay, because all diverging lenses have a negative focal length. It's going to produce a virtual image, which, remember, virtual images are always negative. So we're going to have a negative DI here, and that makes sense because this is a diverging lens. Diverging lenses always produce virtual images, so diverging lenses will always have a negative DI. So we have what we need here. The point of the problem is going to be, if you read carefully, to solve for your DO. So we have our DI and we have our F. This should be pretty easy to do. So again, you're going to want to start with your equation, 1 over DI plus 1 over DO equals 1 over F. And then we'll substitute in our DI, which happens to be negative 0.3 meters, plus our DO, which we do not know, equals 1 over F, which is our negative 0.75 meters. Now, we can take this thing and we can solve for our DO. We go ahead and plug 1 over negative 0.3 into our calculator. We get negative 3.33 inverse meters plus 1 over DO equals, over here, if we take 1 divided by negative 0.75 meters in our calculator, we get 1.33 inverse meters. And then we simplify by adding positive 3.33 to both sides of the equation, and we get 1 over DO is equal to 2.0 inverse meters. And then from there, we just take the reciprocal of both sides, and we get DO is 1 over 2.0 inverse meters, which is equivalent to 0.5 meters. So now again for this, we have an object distance, a DO of 0.5 meters. If we go back, that should make sense because again, all object distances need to be positive. So our object over here, if we look at it, is placed 0.5 meters from the lens. Okay, so that's basically the gist of it. You should be able to go back if you did not get the original notes here through the video. Please make sure you do have the signs of DO, DI, and focal length for all of the lens types. And please go back and make sure you have these sample calculations I've given you. That should give you a good start in being able to complete Dido problems. Good luck.